Hi, I'm Dale from Glenarley Pipes, and today I'm going to do this video on bass drone reeds, the efficiency of them, of the bass drone reeds. So I've got a part of a bass drone. I tried it with the extension, full extension, put the anemometer on the end, and the relative readings at this point and that point were the same. So putting it there just makes it easier to manage. All the reeds are tested at 30 inches. 30 inches is quite a happy to blow chanter reed. Nobody's going to complain about blowing 30 inches. It's not real soft, but it's definitely not a hard reed. And most of the pipers that get reeds off me, they like that pressure. It's around about that pressure. So that's where I'm going with that. I've got a selection of drone reeds here. So we'll just go through and check the efficiency. So I've done a set of readings here already based on a slightly different with the extensions on them, so now I'm going to do the readings without them. So we'll start with this red thing. Now I'm using feet per second on the anemometer just for the Americans. Litres and cubic meters just seems to confuse the hell out of them, so I'll keep it nice and simple. So it's feet per second. Okay, that one's 7.2 feet per second. I've got the anemometer locking on maximum, so I'm just controlling the pressure on that. So 7.2. Now, white one. This big old white thing, big old carbon thing. Zero millimeter. .7 feet per second. I'll try this grey one. .3. Now, old yellow. .4 feet per second. There's a big yellow banded thing. .5 this crozier. I've never bothered about these before, but it was in the box, so I thought I might as well give it a crack. But boy, that thing's edgy. That'd cut you in half, that thing. And pretty efficient just the same, but it would cut you in half. And the brown one, this was the one that was sort of the pick of the litter. We did the test the other day. .7. Now, interesting. The winner was a grey one, and you'd wonder how a little blade at 6.3 feet per second, and you'd wonder how that could use a lot more air. The crozier was 4.1, great big carbon, and it's got a valve hole in it that you could lose a truck tyre in. I mean, I don't know why he's made it that way. Obviously he's got his reasons, but it flies in the face of all engineering logic. But anyway, that's what he's done, and seems to work, and it's not too bad on efficiency. And that one, say, the winner, you wouldn't think. Now, out of all them, ignoring the tone, the red, sorry, was the winner, 7.2. Sorry, grey. The red was the winner, 7.2 feet per second. The best was old yellow at 3.4. Now that's probably a little bit unfair because I've changed that blade. The original blade that came with it was way too stiff to get a good result, so I've changed the blade on that to get a better tone, a less buzzy, less edgy tone, and you know, a much better response and thing. But anyway, that was the winner. The easy came in at 3.7, same as the white one. Interesting. So, point of the exercise is, if you filled your pipes up with the easies, just as for example, because they're the second best, if you filled it up with those, easy to purchase, we know they had a very good result on the startups. They had a good balance over the pressure range. So clearly somebody at that place has worked something out. There's probably somebody there that's smarter than the average beer, and they've just got the engineering right, I guess. There are a few things good about that reed. Nice small blade, and they don't use a very large valve hole. They also position their valve hole, these inverted, so the valve hole's positioned closer to the drone, but even on their non-inverted, they leave a lot of space down here for machining. So they have even on the non-inverted, you can still trim the reed, the body up if you needed to sharpen it for a drone. But as you saw yesterday, you don't need to do that. You can use fillers to sharpen it up and tune it up. So I guess I can see why a lot of people really love using those reeds. But the airflow speaks for itself. So if you were using one of those, you're consuming twice as much air as you are if you're using one of those. and that can't be good for you as a player. The other thing about it is that the strike-ins are worse on those, so you have to up the, even though I've set the pressure on these, the strike-in is worse, is not as reliable, so you'd have to set the reed a little bit harder to guarantee your strike-in when you bump it, which means you're going to have to up the strength of your chanter reed, which is probably not desirable either. So if you select the right reed for your drone, now remember I've done this on one drone, but the numbers relative to each other are fairly accurate. So you could absolutely say that that reed there, definitely, I would say in any drone is going to use more, any base drone is going to use more than the Easy, for example. So that's the results, that's what I've done. You can do with it what you will. If you've got any questions, you know how to contact me.